So in this video, we're going to talk about how to add and subtract rational expressions that require factoring. So remember how to factor polynomials? You always start off by looking for a GCF, and if there is one, you're going to factor it out. Then check the polynomial for any special patterns. Then factor the polynomial using factoring by grouping. So let's try factoring x squared minus 5x minus 24. So there is no GCF, and then there's no special patterns here. So we're going to go ahead and look at the constant term, so negative 24, and we're going to figure out two factors of negative 24 that add up to negative 5. So since 24 is negative, it's positive and negative, and then 5 is negative, so we're going to make the bigger factor negative. So we have 1 and 24, so we make 24 negative. We have 2 and 12, and then we have 3 and 8, and we have 4 and 6. So when we add these together, you can see the first pair gives us negative 23, then we have negative 10, and then we have negative 5. So we're going to go ahead and use these to write out the factors. So we have x plus 3 times x minus 8. So that is the factored form of this expression. So let's try factoring 2x cubed minus 24x. So the GCF is going to be 2, and then we can factor an x out of both terms. So when I factor out 2x, we have 2x cubed over 2x minus 24x over 2x. And so when we do that, we have 2x times 2 and 2 cancel, and then x cubed over x is x squared, minus 24 over 2 is 12, and then x and x cancel. And so x squared minus 12 can't factor, so we're just going to leave that as the factored form of our expression. So now you can go ahead and pause the video and try factoring this expression on your own. So notice that these two terms have a GCF. The GCF is 3. When we factor it out, we're left with x squared minus 4. X squared minus 4 is x squared minus 2 squared, which is the difference of two squares. So we will factor that as x plus 2 times x minus 2. So when we write this out, remember you have to include the GCF in the final factored form of the expression. So we have 3 times x plus 2 times x minus 2. So what we're going to do, the reason we're reviewing factoring is because we're going to add and subtract rational expressions with unlike denominators, but this is going to involve factoring. So remember, you always start off by factoring the denominator of both expressions, then determine what factor is needed for one or both fractions to obtain a common denominator. Then we're going to multiply the numerator and denominator of each expression by a fraction that equals 1 to obtain like denominators. And then once the fractions have the same denominator, you're going to add or subtract the numerators and keep the denominator the same. So let's look at this example. So we're going to start off, what we're going to do is we're going to go ahead and factor both denominators. So let's factor x squared plus 3x minus 4. So we have minus 4, and then that is negative, so we need a positive and a negative factor. 3 is positive, so we're going to make the bigger factor positive. So we have 1 and 4, and we make 1 negative, and then we have 2 and 2 and make 2 negative. Negative 1 and 4 is 3, negative 2 and 2 is 0. So negative 1 and 4 are the correct combination. So we have x minus 1 times x plus 4. Now we have x squared minus 2x plus 1. And so let's go ahead and factor this now. We have 1, so we need two factors of 1 that are going to add up to negative 2. So the two factors of 1 are basically 1 and 1. Since 2 is negative, we're going to need both factors to be negative. So negative 1 and negative 1 do add up to negative 2. So these are going to factor to x minus 1 times x minus 1. So let's rewrite this problem now using the factored form of the denominators. So we have x plus 5 over x minus 1 times x plus 4. And then we're adding x over x minus 1 times x minus 1. So let's look at this and figure out what the least common denominator is. So we're going to take all the factors and we're going to make sure we don't write any repeated factor twice. So we have x minus 1, so I'm going to write that. And then we have x plus 4. And then when we go to the next denominator, we already have x minus 1 written, so we're not going to write it again. But then we have another x minus 1, so we're going to have to include that. So we have x minus 1. So this least common denominator is going to be x minus 1 squared times x plus 4. So what I'm going to do now is I'm going to take each expression and I'm going to figure out how to get the common denominator. So the first expression I'm going to need to multiply by x minus 1 over x minus 1. So when I do that, I'm multiplying that by x plus 5 over x minus 1 times x plus 4. So let's multiply the numerators together. So we have here x minus 1 times x plus 5. So I'm going to use FOIL to multiply these two binomials together. So we have first times first, so that's x squared. We have the outside term, so we have x times 5, which is 5x. We have the inside, which is negative 1 times x, so that's negative 1x. And then we have the last term, which is negative 1 times 5, so that's negative 5. So remember, the two middle terms will combine when we add up all these terms. So we have x squared, 5x minus 1x is going to be plus 4x, and then we have that minus 5 at the end. So the numerator is going to become x squared plus 4x minus 5, and then the denominator is going to be that common denominator that we figured out. So that x minus 1 squared times x plus 4. So now let's go ahead and figure out how to multiply the second fraction to get a common denominator. So the missing factor there is that x plus 4. So I'm going to multiply that second expression by x plus 4 over x plus 4. So we multiply by x over x minus 1 times x minus 1. And so when we do that, that x is going to distribute to every term in that numerator. Okay, so x times x, that's going to be x squared, and then we have that plus 4x. And that is going to be that over that common denominator, that x minus 1 squared times x plus 4. So let's go ahead and put this all together. So we have plus x squared plus 4x over our common denominator. And let's go ahead and combine now the numerators because we have the same denominator in both fractions. So we have x squared plus 4x minus 5 plus x squared plus 4x. And that is over x minus 1 squared times x plus 4. So I'm going to rewrite this so the common terms are together. So we have x squared plus 4x plus 4x. Right? I just rearranged so the like terms are grouped together. And that's over our common denominator. So when we do that, we get x squared plus x squared, which is 2x squared, plus 4x and 4x, which is 8x. And we have minus 5, and that's over x minus 1 squared times x plus 4. So that is going to be our answer, but remember, we always want to double check and make sure that we can't factor the numerator. So when we factor the numerator, we're going to look and we're going to see, we're going to use that a times c method. So like a times c, 2 times negative 5 is negative 10. So now we need two factors of negative 10 that add up to 8. So if you look at the factors of negative 10 that add up to 8, we are going to have positive and negative. Since 8 is positive, we're going to make the bigger factor positive. So we have 1 and 10, and we have 2 and 5. But notice that none of these will add up to 8. So we're going to have to leave this numerator as it is because it cannot be factored any further. So now let's try this example. So let's go ahead and factor both denominators. So 2x can be factored as 2 times x. And then we have 4x squared plus 20x. So the GCF here is going to be 4, and then I can also factor an x out of both terms. So I have 4x times 4x squared over 4x plus 20x over 4x. So when we do that, we're going to get 4x times 4 and 4 cancel, and then x squared over x is just x. Plus 20 divided by 4 is 5, and then x and x cancel. So that is going to be our denominator of the second fraction. So when I rewrite this, I'm going to write this as 2 times x plus 5, and you'll see why I did that when we find the least common denominator. So I have 3x plus 1 over 2 times x plus 4x over 2 times x plus 5. So the least common denominator is going to be where I pull out all these factors. So I have 2 and I have an x. I already had 2, so I'm not going to write it again. But then I have an extra 2, so I'm going to add that. X I already wrote, and then I have x plus 5. So my common denominator is going to be 4x times x plus 5. So to get that 4x times x plus 5 for the first fraction, I need to multiply it by, let's see, I'm missing a 2, and I also need an x plus 5. So I'm going to multiply by 2 times x plus 5 over 2 times x plus 5. So I'm multiplying by 3x plus 1 over 2x. And so when I do that, I'm going to need to first multiply those binomials together. So I'm going to go to the next page. So when I do x plus 5 times 3x plus 1, I'm going to use FOIL. So when I do first, I have x times 3x, so that's 3x squared. Outside, I do x times 1, so we have 1x. Inside, so we have 5 times 3x, so that's 15x. And then we have last, so 5 times 1, which is 5. So now when we add up all these terms, these middle terms are going to once again combine. So we have 3x squared plus 16x plus 5. So remember that we're not just multiplying x plus 5 and 3x plus 1. We also have this 2 in front. So I'm going to also take this expression and I'm going to multiply it by 2. And so when I do that, I'm going to distribute that 2 to every term. So that gives me 6x squared plus 32x plus 10 over, now we have our common denominator, that 4x times x plus 5. Now let's work on the second fraction. Well, the second fraction, let's look at that denominator. It's already 4x times x plus 5. So I don't need to multiply it by anything. It already has the common denominator, so I'm just going to recopy that expression. So I have 4x over 4x times x plus 5. Okay, so I just took that second fraction and I just recopied it because I didn't need to change anything. So when I do that, now I have a common denominator, so I can go ahead and add these two expressions together. So I have 6x squared plus 32x plus 10 plus 4x over 4x times x plus 5. So now I'm going to rearrange this so my like terms are together. So I have 6x squared plus 32x plus 4x plus 10 over 4x times x plus 5. So when we do that, we have 6x squared plus 32x and 4x is 36x, and then plus 10, and that's over 4x times x plus 5. Well, remember, we always want to simplify if we can. So if we look at that 6x squared plus 36x plus 10, okay, notice that there is a GCF, right? So we can actually simplify this a little bit further. Notice that all these terms are divisible by 2. So I can go ahead and factor out a 2 and then simplify this. So a 6x squared over 2 plus 36x over 2 plus 10 over 2. So that becomes 2 times 6 over 2 is 3. So 3x squared plus 36 over 2 is 18. So 18x plus 10 over 2, which is 5. So now that's going to become my numerator. So I have 2 times 3x squared plus 18x plus 5, and that's over that 4x times x plus 5. So notice that now I have this 2 and this 4 that will cancel each other out, right? So I can cancel a 2 and the 4 will reduce to 2. So that leaves me with 3x squared plus 18x plus 5 over 2x times x plus 5. Okay, so I was able to reduce that a little bit because I factored the numerator. Well, let's just make sure we can't factor the numerator any further. If I do a times c, that's 3 times 5, which is 15. So I need 2 factors of 15 that add up to 18, but you can see that we don't have any factors that do that, right? So that can't be factored any further, so we're just going to leave our answer like that. So we have 3x squared plus 18x plus 5 over 2x times x plus 5. So now let's try subtracting these two expressions. So once again, we're going to factor the denominator of both expressions. The first denominator cannot be factored, so we're just going to leave it as is. And then we're going to factor the second denominator. So x squared plus 6x plus 9, you may recognize that as one of the special patterns. That is x plus 3 squared. Or you can just factor it the other way. You can say 9, and then we need 2 factors that add up to 6. So we'll need 2 positive factors. Those are 1 and 9, or 3 and 3. 1 and 9 is 10, and 3 and 3 is 6. So 3 and 3 is the correct combination, so that gives you x plus 3 times x plus 3. So now let's write this with the denominators in factored form. So we have 4 over x plus 3 minus 2x minus 1 over x plus 3 times x plus 3. So when we do that, let's look for the least common denominator. So the first fraction, I get x plus 3. And then the second fraction, well, I already have an x plus 3, so I'm not going to write it again. But then I have an x plus 3 again, so I'm just going to write that, right? That extra x plus 3 does get included. So we have x plus 3 times x plus 3, so that is x plus 3 squared. So we're going to do some multiplication now to get the common denominator. So I'm going to multiply that first fraction by x plus 3 over x plus 3. And so that is times 4 over x plus 3. So all that's going to do is that 4 is going to distribute to every term there. So that gives me 4x plus 12 over x plus 3 squared. Well, look at that. My second fraction is already having the common denominator, so I don't need to change anything. So that's going to be 2x minus 1 over x plus 3 squared. So let's go ahead and just combine. So we have 4x plus 12 minus 2x minus 1 over x plus 3 squared. Okay, so I'm going to rewrite this so that I can, take care of that subtraction. So I have plus negative 1 times 2x minus 1 over x plus 3 squared. Remember, that means I'm going to distribute that negative to every term that's within that parentheses. So that means I end up with 4x plus 12. And then this is going to become a minus 2x and then a plus 1. Okay, so I have minus 2x plus 1, and that's over x plus 3 squared. So now let's rearrange this so our like terms are together. So we have 4x minus 2x plus 12 plus 1 over x plus 3 squared. So 4x minus 2x is 2x plus 12 plus 1 is 13, and that is over x plus 3 squared. And so notice that in the numerator we can't factor anything, we can't simplify it, so we're just going to leave it as is, and that is our final answer. So now let's try this problem. We have x plus 2 over x plus 3. So let's go ahead now and subtract these two expressions. So once again, we're going to factor both denominators. So x plus 4 can't be factored, so we're just going to leave that as is. And then the x squared plus 8x plus 16. Once again, you may recognize that's a special pattern. That's x plus 4 times x plus 4, which is also x plus 4 squared. So we have x plus 2 over x plus 4 minus, and then we have x squared plus 4x over x plus 4 squared. So if we look at the least common denominator, we have an x plus 4, and then we're going to pull one of the x plus 4s from the second denominator, right? So we have x plus 4. So x plus 4 squared is going to be the least common denominator. So to get that, the first fraction, we're going to have to multiply it by x plus 4 over x plus 4. And so when we do that, this is what we get. So once again, I'm going to FOIL that. So I'm just going to go to another page, and I'm going to FOIL x plus 4 times x plus 2. And so I do first times first, so that's x squared, plus outside x times 2, so that's 2x, plus inside 4 times x, so that's 4x, plus last times last, which is 8. So when I combine these two middle terms, I have x squared plus 6x plus 8. So that is going to become my numerator here. I have x squared plus 6x plus 8 over x plus 4 squared. Notice in the second fraction, I already have my common denominator, so I can go ahead and put these two rational expressions together. So when I do that, I get x squared plus 6x plus 8 over x plus 4 squared, and then minus all of x squared plus 4x. So remember, what's going to happen here is I'm going to change that minus to a plus negative, and then I'm going to distribute that negative 1. So this is going to become x squared plus 6x plus 8 minus x squared minus 4x all over x plus 4 squared. So I have x squared plus 6x plus 8 minus x squared and then minus 4x all over x plus 4 squared. I'm going to rearrange this with my like terms together. So I have x squared minus x squared plus 6x minus 4x, and then plus 8, and that's over x plus 4 squared. So now when I combine my like terms, x squared minus x squared is 0, plus 6x minus 4x is 2x. So I have 2x plus 8, and that's over x plus 4 squared. So now I have 2x plus 8 over x plus 4 squared. Remember, you always want to simplify, so that 2x plus 8, if you look at that, it does have a GCF, right? It has a GCF of 2. So I'm going to factor out that 2 from both terms. And when I do that, that gives me 2 times x plus 8 divided by 2, which is 4. So I have 2 times x plus 4 over x plus 4 squared, which is basically x plus 4 times x plus 4. So that means that one of these x plus 4s can cancel, so my final answer is going to be 2 over x plus 4. So that is the simplified expression that is the answer. So now you can go ahead and pause the video and try doing this example on your own. So in this, we want to once again factor both denominators. So the first denominator is x times x minus 5. The second denominator will be 4x minus 20. So that is going to be 4 times x minus 5 because that is a GCF of 4. So the least common denominator is going to be 4x times x minus 5. So the first rational expression we need to multiply by 4 over 4. And the second one we need to multiply by x over x. So when we do that, we get 4x plus 20 plus x squared plus 3x. And we can combine all of that. So when we rearrange this, we have x squared plus 4x plus 3x plus 20. The 4x and 3x combine to give you 7x. So we have x squared plus 7x plus 20. Notice that we want to see if we can factor it. So you're going to look for two factors of 20 that add up to 7. The factors of 20 are 1 and 20 and 4 and 5. But if we add them together, we don't get 7. So we're going to leave this as the final answer because it can't be factored any further. So remember, to add or subtract rational expressions with unlike denominators, you can factor the denominator of both expressions, determine what factor is needed for one or both fractions to obtain a common denominator, then multiply the numerator and denominator of each expression by a fraction that equals 1 to obtain like denominators. Once the fractions have the same denominator, add or subtract the numerators, and then keep the denominator the same.